I'm Don Mockholtz, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 8 for the week of February 26, 2020. The related website for this podcast is donmachholtz.com. That is spelled DONMACHHOLZ.com, 2 H's. So, what's up in the sky this week? As our week begins on Wednesday, February 26, the moon is a thin crescent in our evening sky, growing larger and brighter each evening and setting about an hour later each night. On Wednesday, the 26th, the moon joins Venus in our western sky. It passes 7 degrees south of Venus at about noon Universal Time on the 27th. So by the evening of the 27th, seen from the Western Hemisphere, the moon will be above Venus. So it will be below Venus on the 26th and above Venus on the 27th. This is a good photo shoot opportunity. By March 2nd, the moon will be first quarter, which is a great phase for lunar browsing. Those interested in lunar observing or observing anything in the solar system might consider joining the Association of Lunar and Planetary Observers. This group, also called ALPO, A-L-P-O, issues a journal 4 times a year full of studies and summaries of everything in the solar system. And each month, it also issues a 30-page digital booklet on observing the moon. You can get the digital downloads for sun's activity and for comets each month. To join the Association of Lunar and Planetary Observers, go to their website, fill out the form, and become a member. The cost is only $18 a year. ALPO also has a free service. The podcast is called Observer's Notebook. Every few weeks, a new Observer's Notebook podcast becomes available, highlighting specific solar system topics and interviewing some of the top solar system experts. So get out there this week and take a look at the moon. Venus continues to lurk in our southwestern sky, and once again take another look at the star Betelgeuse. How bright is Betelgeuse this week? Well, you can make a magnitude estimate of its brightness, and for this, use Star Map 1 for Podcast 8. Estimate how bright Betelgeuse is this week. In our morning sky, we have a rare opportunity to see 3 bright planets in a row, equally spaced apart on the morning of next Tuesday, March 3rd. The last of those 3 planets, Saturn, rises just 2 hours before sunrise from mid-northern latitudes. But once it clears your horizon, you will see from upper right to lower left Mars, Jupiter, and Saturn. On Tuesday, March 3rd, it will be 8.5 degrees from Mars to Jupiter and 8.5 degrees from Jupiter to Saturn. This is another good photo opportunity. If you'd like to step outside and see the International Space Station this week, those in the northern hemisphere will see it in their morning sky. For those in the southern hemisphere, it will be visible in the evening sky. Now, to find out where it will be in your sky, go to the website heavens-above.com, enter your location, and find out where and when to see it. The website, once again, is heavens-above.com. You can find the location of thousands of satellites on that website. For these next 3 items, you might want to download Star Map 2 of Podcast 8, and you can find that on my website, donmachholtz.com. Our unaided eye challenge this week is to learn another constellation. That constellation is Canis Major. It's known as the Big Dog. There's another constellation known as Canis Minor. That is the Little Dog, but we're only going to learn Canis Major this week. This constellation is in the southern winter sky and is shown on Podcast 8 Star Map 2. It kind of looks like a dog from the northern hemisphere standing on its back legs. The brightest star in Canis Major is Sirius. That's the brightest star in the sky, magnitude minus 1.46. It's considered to be fairly close to us at a distance of 8 light years. So the light you see left that star 8 years ago. It's a hot star, it's blue in color, and you'll notice that many of the brightest stars in the constellation Canis Major are hot and blue. So get to know this constellation. The binocular challenge for this week is an open star cluster known as M41. It's the 41st entry in the catalog assembled by Charles Messier more than 200 years ago. This open cluster is about 2,300 light years from us, and it's about 12 light years across. Now, the way to find it with binoculars is you start with the bright star Sirius. That's the brightest star in the constellation Canis Major, and go south 4 degrees. Now, the cluster has about 100 members. It does stand out against the background sky. And while you're going between the star Sirius and M41, about halfway distance between those two objects was the location from where my first comet was when I discovered it in 1978. Our telescopic challenge this week is an open star cluster known as 2362, and it's also in Canis Major. This open star cluster consists of about 60 stars, but they're packed into a small area that's only about 6 arc minutes across, or about 1/10 of a degree. It sits at 4,800 light years from us, about double the distance as M41. A bright star of 4th magnitude sits near the center of this cluster. Go out there and give it a look. Our fun fact this week is about leap year. So why do we have an extra day every 4 years? This is why. The Earth revolves around the sun, and as it does so, it rotates on its axis, with each rotation being a day. And for our illustration, a day is from when a particular point faces the sun until the Earth rotates around and faces the sun the next day. So, the Earth rotates as it goes around the sun. When it gets back to where it started, we call that a year. And guess what? It's rotated not 365 times, but 365 and a quarter times. So after 4 years, we've gained a day. We can't just keep gaining a day every 4 years, or the seasons will get out of whack. After 60 years, if your birthday was, say, October 7th, the Earth and seasons would be as they would be on October 22nd on October 7th. So you mark your birthday each time the Earth goes around the sun one full time. On your 60th birthday, if you were born on October 7th, the Earth would have completed 60 revolutions around the sun, and that day would be September 22nd. So your birthday would actually be a quarter day earlier every year. And if no leap year was added for 360 years, then 90 days of Earth travel would accumulate, and it would be springtime in December. So every 4 years, we add an extra day to the calendar to keep things under control. We add it to the end of February every 4 years. Well, every 4 years except for the years 1700, 1800, 1900. In the year 2000, we had a leap day added to the year 2000. That is because, to be more accurate, the Earth rotates 365.2 3.2425 times, not 365 and a quarter times. And we will add a leap year to the year 2400 too, but not to the years 2100, 2200, and 2300. That probably doesn't matter to you in a practical sense. This year we have February 29th, an extra day. Do something special that day. It is fun to run the Messier Marathon. And what is a Messier Marathon? It's a yearly activity to observe all or nearly all of the 110 galaxies, clusters, and nebula in the Messier catalog, and to do all of those 110 objects in one night. The best time to do this is in late March of each year, and it does depend upon the moon phase. With the new moon on March 24th this year, most astronomy clubs will be doing this on either March 21st or March 28th. To successfully run the Messier Marathon, it helps to have an observing order or a search sequence. You can download one from my website. It is in Podcast 5, Search Sequence. You might also want to download 2 more maps while you're at it. Podcast 8, Map 3, 4, and Podcast 8, Star Map 4, 5, which show the Messier objects that we'll be discussing this week. When we left off last week, we had seen the third set of Messier objects of the Messier Marathon and covered 48 of the 110 objects, all of them in the evening sky. This week we'll be covering 22 more objects. We are now ready to enter the many galaxies in Virgo and environs. Some of those doing the marathon fear this area the most. I have heard of folks spending more than an hour to pick up these next 17 objects. In fact, I've heard of people spending 2 hours going through this area. And sometimes people start this area and then they just give up. This is enough to discourage amateur astronomers from doing the marathon. There's 3 points here to help you through the anxiety. Number 1, to be sure, there's a lot of galaxies in this area. But with a few exceptions, the Messier objects are brighter and bigger than most all of the non-Messier objects. So we're looking for the bright galaxies here. If you find some faint ones, and you will, they are probably not Messier objects. Number 2, these objects are fairly close together, within a few degrees of each other. So after you use your finder to find the first object, you can stay at the eyepiece and go from one object to the next. Number 3, it helps to practice in this area before marathon night. Run the sequence backwards and forwards until you feel comfortable in this area. We start with the star Denebola, the bright star at magnitude 2.1, the last star in Leo, the tail end of the triangle in Leo. From here we go slightly north, about 0.3 of a degree, and 6.8 degrees following, that is east, to the star 6 Coma Berenices. It is magnitude 5.1, but it's the brightest star in the area. From here, we're going to star hop to our first object, M98. By the way, we will be going eastward and then either north or south as we go from object to object, with only a few exceptions, and I'll point those out as we get to them. So to find M98, go back towards where you came from, but only a half a degree. There you'll find one of our faintest and most difficult objects, M98. It's about 3 times longer than it is wide. Now we're going 0.5 degrees south and 1.2 degrees east to M99. You'll go past that star that we had found a few minutes ago. M99 is round and slightly brighter. If you're following along on the map, or if you're at the telescope and listening to this and moving your telescope whichever way I suggest, This should not be too difficult. Our next object is M100. Now this is a longer leap. It's east 1 degree and north 1.4 degrees. M100 is diffuse. It's slightly larger than M99, and it has a tendency to blend in with the background, but nothing else in the area is this bright. M100 has been known to have supernova in it, so you might want to just check and see if you see any bright stars nearby. Now we continue heading northward for our next object, M85. Continue east another 0.6 of a degree, then north 2.4 degrees to M85. M85 is the brightest object so far in this sequence, and you can confirm that you have it by looking for a fainter galaxy to its east. Now the next sweep is a long one, but it takes you to two galaxies of equal brightness and appearance next to each other, and these are the brightest two galaxies in the area. We're going to head 5.3 degrees south to M84, and just east of it is M86. They're like twin galaxies. They're about 0.3 of a degree apart. If you look around the area, you'll find quite a few fainter galaxies, but those are not the Messier objects that we're looking for tonight. Our next galaxy is M87. To get there, go 0.6 of a degree south and 1.1 degrees east. M87 is about as bright as the last two galaxies, that is about 8.8 magnitude. It has a black hole, but don't expect to see it. Our next target is M89. It's a bit fainter than M87, and to get there, go 0.2 degrees north and 1.2 degrees east. M89 is round, magnitude 9.1. Our next object is a bit more difficult to see. I've sometimes had some trouble with it because there's a few other galaxies in the area that could be mistaken for it, but it is M90. It's the same brightness as M89, but it's twice as long as it's wide. To get there, go 0.3 degrees east, then 0.7 degrees north. That's M90. For our next galaxy, we are going to go west, not east like we have been doing. So go west 1.2 degrees, then 1.2 degrees north. You will find M88. It is a very obvious galaxy. Nothing is this bright in this area. Our next object is one of the original missing Messier objects, M91. It's now believed to be NGC 4548. To get there, simply go east 0.8 of a degree. It is faint, it's magnitude 9.9, and it's round. Are we having fun yet? I hope so. You know, if you have an equatorial telescope and you have this podcast out under the stars and you're at your telescope listening to it, you could find these objects as quickly as I'm going through it by moving your telescope this way and that. And when you're done moving at those locations, you will find the object in your eyepiece. Our next hop will take us to three brighter galaxies. The first of the three is M58. Now to get there from M91, go 0.6 degrees east, then 2.7 degrees south. Now, as you go south, you will run into an old friend, M90, which is halfway between 91 and 58. Now, M90 we saw a few minutes ago, but you'll be passing it as you go between M91 and M58. Now, M58 stands out, and it's fairly large. From M58, go 0.2 degrees south and 1.1 degrees east to M59. Now, M59 looks similar to M58, and to get to the third galaxy in this group, that's M60, we continue east another 0.4 of a degree. So those three galaxies, M58, 59, M60, kind of in a row running east to west. You will know you're at M60 if you see another much fainter galaxy on the northeast edge of M60. That galaxy is 4647. It's an NGC number. It's not a Messier object. It's just next to the Messier object M60. We have 3 more galaxies to hit in this area, and they require some large hops. Our next target is M49. Now, most of the time we've been going east, but this time we're going to go west, 3.5 degrees, and then south 3.5 degrees. M49 is the brightest galaxy in this area, but there's a lot of fainter ones here too. We are still in the area of faint galaxies as we head over to see M61. To get to M61, we continue westward, this time 2 degrees, and then 3.5 degrees south. M61 is a round galaxy, and if you look carefully in the area, you'll see some fainter galaxies nearby. The last one in this area is M104. Now, it's 17 degrees south, so the best way is to start at the northeast bright star of Corvus and go 5.5 degrees northeast to M104. You can use the star map from my podcast to hop over to M104. So we have just gone through a whole bunch of galaxies, the most feared section of the Messier Marathon, but that wasn't too hard, was it? Take a break. If you have been hurrying along for these first 65 objects, you might have to wait for the next object to rise above the horizon. And if not this one, then the next one. This happens to me frequently. In fact, most Messier marathons, within the first hour and a half, I have picked up all these objects, and I've covered just about everything that's above the horizon. Our next object is M68. It's a globular cluster south-southeast of the southeast star of Corvus. It stands out really well. Our next object rises more than an hour after M68. It's M83, and there's no easy guide stars nearby. But it is bright, magnitude 7.9, and it's large, 10 arc minutes by 8 arc minutes. If you have a moon in the sky, it might tend to fade out in the moonlight. But once M83 is up, our next 3 objects are at about the same altitude. All of them are globular clusters, and all of them are bright. M5 is bright enough to be seen with the unaided eye, but probably not at this altitude. From here we go to M13, also equally visible. Finally, continue your trek to the left to M92. So there you have it, the first 70 objects of the Messier Marathon. You've covered 63% of the Messier catalog. Congratulations. You have hit the wall in this marathon and continued on. Next week, we'll start on the summer Milky Way, and things will get a bit easier. You have been listening to Looking Up with Don, podcast episode 8. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. This is where you get all these free star maps and the search sequence for the Messier Marathon. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's going on in the sky, the next segment as we work our way through the Messier Marathon, and we'll talk a bit about joining your local astronomy club. Thank you for listening. See the sky this week? I'll see you next week.